we're going to look at how to do some crazy flying motion. So go to the fly class and let's make another method. Let's call it fly and put self in here. We're also going to be needing the screen width later on, so just get that too. So start off with do self.rect.x plus equals self.velocityx. You guys probably know this routine by now. And of course we declare self.velocityx. But we want to give our flies some variety. We don't want them all to be going at the same speed. So I'm just going to do rand int. So they're going to be going either from 1 pixel per second to 4 pixels per second. And that's going to be determined right when they're born. But rand int isn't a built-in Python function. Well, it is, it's in another module called random. So if we scroll up our document, oh, see, I had already imported it. But I don't want to import it like that. I want to import it like this. From random import rand int. There we go. So now we have a random speed for every fly. The next thing we're going to do, actually before the bug flies, we're going to check if our bug has hit the wall yet. So self.rect.x plus our flies width is greater than the screen width, or let me move this over, or self.rect.x is less than 0. And delete that, and alright. So remember how when we press the A and D keys on our keyboard, our bug changes image. But instead of creating a new image for every new direction you want your bug or fly to go in, you can simply use a built-in Pygame module called transform to do that for you. So we're going to directly manipulate our fly's image using self.image equals pygame.the transform module flip. And what we want to flip? We want to flip the image itself. And right here are two booleans, x and y. Do you want to flip on the horizontal axis? You say true. And do you want to flip it on the y-axis? No, we don't, so we want to put false. Like that. And self.velocityx, meaning the direction the bug is flying in, is going to equal the opposite of itself. So self.velocityx. So I just put a negative in front of it. Oh, I think that's all good. And the next thing we're going to do is going to be a little funky, but it's really cool. So if you have any sort of background in trigonometry, you will know what a sine curve is. And the formula for a sine curve is A times sine of bx plus c, and in our case, plus y. Oh, plus y. A stands for the amplitude, so the maximum height our wave can go. B is for the period. X is the X position. C is the shift. We will not be using that. And Y is how high our bug is flying. So let's do that right now. Actually, before, it'd be smart to declare some variables up here. So self dot amplitude and self dot period equal. Actually, I want to randomize these ones as well. So rand int. And I have found really neat values for these, so you guys can just copy them from me. So 20, 140, and random int 4, 5 divided by 100. This is going to be a decimal, but you have to pass integers in for your rand integer function, so that's what I did. And it's going to turn out to be a decimal anyway because I divided by 100. Alright. And the reason it's between 20 and 140 is because our amplitude is going to be either between that. So we know our bug will not necessarily be going off screen too much, and it's not going to be flying too high or too low, but just in the middle. So that's a fair range. So what we're going to do next, we're actually going to set the Y position equal to this formula right here. So self.rect.y equals, it's not plus equals, just equals our amplitude times math.sine. I'm going to go import that later. Hopefully I won't forget. Next up is our period. Self.period times .rect.x. Let's shift this over a little bit. Is that it? No. Plus 140 approximately. So this is how much down it's going to be. Let me just check if I don't have any errors. Seems legit. Okay. Just run it, see if everything goes. Actually, I need to say our fly. Oh crap. Control Z. Fly and screen width. And I get a load of error. Alright, that math module. Damn it. Math. Okay. Oh, check that out, guys. Check that sick fly motion. It hits the side, and you saw how it like flipped the image and switched the direction it was in. Perfect. Now what we want to do is actually create more of these bugs, or flies. So as we're creating more flies, it's convenient that we don't have to say fly, fly, fly like that, but that we actually have one command telling all our flies to fly, basically. And this is where this variable is going to come in handy, list. So now I'm just going to create another method called movement. Sure. And this is going to be a static method actually. So get your @ sign. At static method. And what's so special about static methods is you can call them using the class name. So like this, fly dot, well in this case it would be movement. And also in static methods there is no self because it's a class method, not an object method. So always take that in mind. And so for flies in fly.list, flies.fly. So we're using an object, flies, or maybe I should just call it fly, that'd make more sense, but it makes this look weirder. So for a fly in our fly list, we're going to make that fly fly. And of course you're going to need screen width. Awesome. I think that's it, honestly. Just double check for errors. I think we're good. So now if we go up here and we create more flies like that. One more, why not? Fly 1, fly 2, fly 3. Let me change their height, so it's gonna be crazy. And now we call it the class name and not the actual object itself, and movement with screen width. If I run it, oh my god, check those flies going crazy out there. And every time, slowpoke right here, every time I rerun this, there'll be a new set of flies. You'll notice that each fly is flying like approximately the same speed, and that's because our velocity x is always going to be either 1, 2, 3, or 4. But this won't matter when we will be automatically generating flies every couple of seconds, so they won't be flying like this in unison all the time. So I hope you guys enjoyed this tutorial. Hope you learned something.